So this time, we're not just simplifying, we want to actually work it out. So what do you think is the first thing we should do here? Anybody? Mm-hmm. Yes. Right, there we go. We have to start off from there because we need to understand that when we have rational powers like these indicate that we're taking the nth root of the number. And when I say nth root, whatever is the denominator, that is telling me which root I'm taking. So because this one is half, this one, I'm going to take the square root of 81. And then we'll deal with 27. So I want you to think about that. If it's power is 1/3, what will we be doing with that number when we get there? Alright? So yes, we start off by taking the square root of 81. Right? So it's the square root of 81 multiplied by 27 to the power of 1/3. Anybody wants to tell me what we're doing with that? Mm-hmm. Correct. You're going to do the cube root. So we'll do the cube root of 27. Okay, so what is the square root of 81? And we're considering positive values, right? We're just considering positive values. Nine. And what is the cube root of 27? 3. So 9 by 3 will give us 27. Alright? So that's how we will work out something like that. Okay, let's try one more. Yes. Yeah, so if it's 1/6, it will be the 6th root. If it was 1/7, it would be like the 7th root. So it's whatever is the denominator that is indicating to us which root we're taking. Alright, so from here, let's take a look at... oh yeah, we can look at this one. Don't be too intimidated by it. Let's say we have something like this. I mean, if I wanted, I could make it a little bit more difficult, but try this one. What would we do here? So maybe we get a little silent because we see a negative power, but think about it. Think about what we just looked at. Just that this time you have a negative. Who was that? Was that Tamika? Mm-hmm. Somebody help her out. She's trying. What do we do in... Okay, what do you all want to do with a negative power? That's the first thing you need to ask yourself. What do you want to do with a negative power? Do you want to... You want to get it like this, yeah? You want to express it as some kind of root of the number. But the negative. Do you want to... Do you want to get rid of that negative power first and then express it in this form? Yes. So let's try doing it that way. So if we try to get rid of this negative, which rule should we apply here so that we'll be able to get rid of that negative power? Help out is something to do with the reciprocal. Somebody tell me. What do we need to do if I want to get rid of a negative power? Say it back. Mm-hmm. That's it. You have to inflate. So just remember the rule that we talked about earlier. If we have any base raised to a negative power, so just in general, this one for the negative 1, you always write it as 1 over e. But last term I showed you all as well, it can be extended to absolutely any power. So if I had e to the power of negative n, I could write this as 1 over e to the power of n. Alright? So using this part, this extension of that rule, do you think you understand better what you need to do with this? Because now we're not looking at just the power of negative 1, we're looking at any power in general, any negative power. So how would I write 32 to the power of minus 1/5 so that I don't have a negative power anymore? If I have 32 to the power of negative 1/5, right? And I want to rewrite it so that I no longer have the negative power, how am I using my rule here to change this so that I no longer have that negative power? Okay, it will be 1 over 32 to the power of, check back again. So if it's negative n, we drop the power down and it becomes positive, right? So you're correct here, 1 over 32, but this piece now is the 1/5. What we actually need to remember is that n could be, whether it's a whole number, a rational. When you use this rule, if this is 32 to the power of negative 1/5 here, when you drop it down, it becomes 32 to the power of 1/5. Because n is your power, n is whatever is the numerical value. The negative sign, we dealt with it when you did the reciprocal. Making sense? Okay, I hear one yes. Is that okay for everybody else? Okay, so hearing a few yeses. Alright. I want to make sure that you'll understand how to apply your laws of indices, especially with these types of problems, because let's just say it comes as a multiple choice question for exams. You don't want to lose a mark by guessing. You want to at least know for sure that you have the correct booking, alright? So while this might look unnecessarily weird, it will work out nicely in a little bit, alright? Okay, so I see Kyla just message, just give me a second. Alright, so Kyla said she's lost. Renelle said she's lost. Okay, we're going back again. Where did you all get lost at? Start from there. Where did you all get lost at? Okay, I have a question for everybody. Is negative 1/5 negative 5, or is it negative 1/5? It's negative 1/5, right? So remember what I was saying here. This n doesn't have to be just an integer, just 5 or just 3 or just 2. It could be rationals. It could be a half. It could be 1/3. It could be like what we have right now, 1/5. So the point that I'm trying to get across here is that when you're dealing with indices, indices don't only come in integer form where you're just dealing with a negative number or positive number. You could be dealing with negative rationals, and you need to know how to deal with them. Alright, so that's why I said these would be a little bit more challenging, especially with the fact that you have a negative rational here. Now, if I have negative a to the negative n, when I say a to the negative n, this is something that I need for you all to kind of practice doing. If you know you don't understand fully how to apply laws of indices, you're going to need to do this. Instead of just trying to learn it off, which is what everybody's do, and then just try to look at a question and I don't know, like just try to see how you just use it. Put it into perspective. This is the number that I am dealing with. I am dealing with a 32 to the negative 1/5. Go back from the very beginning when I showed you all how to identify things like this is a base. Y'all remember that? This is a base. This is what we refer to as the base. So if this is the base, this is my power, or my index, whichever way you prefer to refer to it. Alright? Now, let's try comparing it with the rule that we want to apply. What is E? Anybody, what is E? Precisely, it's the base. Okay? So if A is the base, what is negative n? The power or the index. Alright? So Renal and Kyla, you all following so far, right? Yeah? Renal, you can message in the chat. Okay, nice. So I have the base, I have the power. Now, as it is, some of the things in maths that we don't like, negative powers. Really and truly don't like negative powers. So this is one of the reasons why, in preference to working with a negative index, we try to find ways to make it positive so that it will make our lives a lot easier when we have to go simplify and evaluate stuff. So here, I know that my base is 32. Alright? I know my power is negative 1/5. So what I want you all to do now, if I have to, so let me just erase some of this now, right? If I have to compare this 32 and 32 to the power of minus 1/5 to a to the n, can you all identify for me? Right, I rewrite the whole thing and done. Okay, so there we go. So we have 32 to the power of negative 1/5. And we said that we're comparing it. Just give me a second. Let's see. Okay, yeah. 32 to the power of negative 1/5. If we're comparing it to e to the power of negative n, look at it. Can you compare these two things for me? And if I were to ask you, well, okay, in the comparison, which value is a? Which value is n? Can you all tell me the answers to that? Which value is a? Thank you, right? So a is 32, and as she said just now, negative n is a negative 1/5. Now, if I wanted just n only, what would you tell me is the value of n? Just n alone. Alright, just now, you have the negative 1/5 and negative n. Look at it carefully, right? Negative n is negative 1/5. So if I want n alone, n would be 1/5. Yes, Skylar, n would be 1/5. So is it making a little bit more sense now what I'm talking about when I say, okay, a to the minus n is this 32 to the minus 1/5. So now if I want to rewrite it so I no longer have a negative power, I'm going to rewrite it as, look at it, 1, so you see the 1 over here, 1 over A, we said A is 32. So you'll see where the A come from again. A is there. And now N, remember, like I was just pointing out, she said minus N is minus 1/5. Now if I want N alone is the 1/5 itself. And this is the reason why that 32 to the power of minus 1/5 becomes 1 over 32 to the power of 1/5. So just checking, is it clearer for everybody? Okay, so Kyla understands now. Renal, does it make a little bit more sense to you why it's going to go as okay? All right, so Renal understands as well. All right, so this is what we want to always ensure we do if we have any. I'm so surprised when someone can write so neat with numbers. Yeah. So, like I was saying, it's always really, really important. If for some reason you're not understanding how to apply these things, just remember you can always just compare the parts of your rules to what you are looking at. So if you know you're going to apply a specific rule to a specific numerical statement, ask yourself, if you compare the rule to the numerical statement, which one is, in this case, which one was A, which one is N, and if I have to rewrite it as 1 over A to the N, once I know who's A and I know who's N, I'm going to be able to rewrite the statement properly. Alright? So, like I was saying, once you get through that part, alright, all this will start to make sense now. How to simplify these negative powers. And one thing for certain, a lot of people don't like negatives, they don't like fractions, they don't like algebra. And indices basically take all that and make one topic, right? So this is one of the reasons why, if you are definitely the type of person you have a little challenge with any of those three things, you're going to have some issues. Alright? So make sure to go over all those things, like I said. Make sure that you're familiar with your ability to distinguish between a rational, an integer, naturals, whole numbers, those things. Alright, so here we go. We just need to simplify, well, not really simplify, but apply the other laws to, simplify it a little bit more, and then we'll be able to evaluate it. So now that we have this here, now we get rid of the negative power, just like we did with this example, we're going to express it in this particular radical form so you could work it out. Alright? So if I have 1 over 32 to the power of 1/5, you're going to apply the rule mainly to this piece here. It's just that it's going to look a lot like this, which, you might be at first thinking to yourself, oh my goodness, I never do anything with this before. What am I supposed to do? Alright? But you're accustomed to this form. Alright, so we could work this out just like this one. It's just that instead of getting a whole number, you're going to get a rational over here. Alright? So what is the 5th root of 32? Anybody? Okay. Waiting. Think about a number you need to multiply by itself 5 times and you'll get 32. It's 2. So we'll get 1 over 2. So we get a half. Alright? Multiplied by the cube root of 27 is 3. We worked that out before. And a half by 3. What is the answer? A half by 3. I just heard somebody say 1.5. Yes, we could write it as irrational form 3 over 2, or you could write it as 1.5. Or 1.5. Up to you. Okay? So, all those are acceptable answers. 3 over 2, 1.5, 1.5. Alright? So that's how we would apply our laws of indices to simplify numerical statements to be able to evaluate them. Alright? If it's anything, I would try to get some revision materials together. We do have another session Thursday before the Epiphany service. So on Thursday, I'll try to bridge into the new stuff that we have to do this time. So make sure that you'll review, like I said, your laws of indices as well as your quadratics, because quadratics will come back again come back around this too. And we do have a lot of things involving graphs and functions and inequalities, so things from form 2, things from form 3, you're going to see it again. So let's see.